Good morning, boys and girls. Today we are going to review and discuss and perhaps even learn something new in both the area of factors and divisibility. First of all, let's begin with a definition. Following along in your book on page 89, we read that a whole number factor is a whole number that divides another whole number. Factors are all the numbers that we can divide into another number. Let's look at some examples and you will quickly get this one figured out. For example, there are 4 whole numbers that divide 6. These 4 numbers are 1, 2, 3, and 6. All these numbers are factors of 6. If you look at this example, 6 divided by 1 equals 6, 6 divided by 2 equals 3, 6 divided by 3 equals 2, 6 divided by 6 equals 1. So when we're asked to consider factors, one of the things we can do is simply think about our multiplication facts and what we know about multiplication. And in the case of 6, we would ask ourselves, what is every single combination of whole numbers that we can multiply in order to get a product of 6? We also could perhaps be drawing pictures and making those even groups of rows and columns and ask ourselves, what are all the possible combinations that we can use of rows and columns to create something, a shape, using our 6 blocks. Looking at example 1 on page 90, we are asked, what are the factors of 10? Well, remember, the factors of 10 are all of the numbers that divide 10 with no remainder. And in fact, those numbers are 1, 2, 5, and 10. We could use models. We could take 10 little cubes or blocks and make all of the different combinations to create a rectangle, an even group of rows and columns using only 10 squares, and we would see these sorts of drawings. But we can also write out our factors using the following method. This is the method you will soon be using exclusively, and I kind of call it a teeter-totter or seesaw method. I begin by writing the number out that we are trying to find the factors of, and then I put a colon. 2 dots, one on top of each other. 1 is a factor of every number because 1 times that number always equals that number. Here's where we get going with our teeter-totter. Now, while this method may leave you with a list of numbers that have a big space in the middle, it's also a very effective method for making sure you get all of your numbers. So we begin this way. We start with 1, ask ourselves, 1 times what equals 10? And the answer is 10. If you remember, that's because of the identity property of multiplication. Now we teeter-totter, tip back over to the beginning and go and ask ourselves, is 2 times anything equal to 10? And you'd say, sure, 2 and 5. We tip back over. Now come back to the beginning. Is 3 times anything equal to 10? No. 4 times anything? No. 5 times anything? Yes, but we already have 5 recorded. We don't need to record it again. Therefore, we see that the factors of 10 are 1, 2, 5, and 10. Now I know the way I did it has left kind of a big gap, but it's a very orderly and systematic way of seeking out and finding factors. As you find more and more factors for different numbers, you'll get better and better at gauging how much of a space you need to leave. Let's try factoring another number again, just so you can see this method. Let's find all the factors of 12. So I wrote 12 with a colon. We always begin with 1, tip over to the other side, 12. 2 times 6 equals 12. 3 times 4 equals 12. And do you see where if these numbers were written out in order, we've already reached the point? There's no point in asking any more numbers because they've already been recorded down over here. And our list of factors for 12 is complete. We will do this often, and we will do this together as a group. Oh, in fact, without realizing it, I went ahead and did example 2 for us. How many different whole number factors are there for 12? Well, there's 1 and 12, 2 and 6, 3 and 4. Therefore, there's a total of 6 factors. All I did is count my factors. And if we were to have drawn out our examples, we would have seen the combinations of 1 and 12, 2 and 6, 3 and 4. Now let's take a quick peek at the idea of divisibility. Especially as we move into larger numbers, it is very helpful to know if a number is divisible by 2 or 5 or 10 or even 3 or 4. We already know some of our divisibility rules, but there are a few neat tricks for learning some of even the other numbers as well. There are ways of discovering whether some numbers are factors of other numbers without actually dividing. For instance, you already know that any even number can be divided by 2. Therefore, 2 is one of the factors of every even number, because we are able to divide the number by 2. But now let's look at some other tests. Again, this might be a page you want to mark until you learn all these tests. Typically, what we do when we decide if a number is even or odd is we look at that last digit. Well, there are several ways we can look at the last digit in order to learn the divisibility of various numbers. For example, we use the last digit test, which means looking at the last digit of any number. And the number is divisible by 2 if the last digit is even. The number is divisible by 5 if the last digit is 0 or 5. And the number is divisible by 10 if the last digit is 0. Let's look at just a few examples for 5 and 10. I think you're already pretty comfortable with the idea of identifying whether a number is even or not. Remember that if it's even, 2 is absolutely one of the factors. It is divisible by 2. Let's look at a few numbers here. I'm just going to write them out. Okay. So in the case of 45, we look at the last digit, it's 5. Our rules tell us that if the last digit is 0 or 5, it is divisible by 5. And in fact, you know that 5 times 9 equals 45. In the case of 50, the last digit is 0. Looking at our chart, this number should be divisible by both 5 and 10. And in fact, 5 times 10 equals 50. In the case of 75, the last digit is 5, therefore the number is divisible by 5, and if you give this a thought, we would remember that 5 times 25 equals 75. In the case of 90, the last digit is 0. Therefore, this number should be divisible by both 5 and 10. In the case of 10, we know that 10 times 9 equals 90. I'm not exactly sure what 5 times what we multiplied by 5 by to equal 90, so I'll do a quick division. 90 divided by 5 is in fact 18. So 18 times 5 equals 90, and we learn that 90 is truly divisible by both 10 and 5. It gets even better, boys and girls. Let's look at two special rules that will help us determine if a number, any number, is divisible by either 3 or 9. This particular test is called the sum of digits test. The way we check for divisibility by 3 is to begin by adding the digits of the entire number and inspect the total of the sum of the digits. A number is divisible by 3 if the sum of the digits can be divided by 3. And a number is divisible by 9 if the sum of the digits can be divided by 9. Now let's look at a few examples. I'm not going to do example 3 with you, but I am going to do example 4. Let's look at these numbers. First of all, we have 3, 6, 5, then we have 1, 1, 7, 9, and 1, 5, 5, 6. I'm going to move my paper up. The way to check for divisibility by 3 is to add this and find the sum of all the digits. So 3 plus 6 plus 5 is 14. Ask yourself, is 14 divisible by 3? The answer is no. Therefore, this number is not divisible by 3. Let's add up the sum of the next number. 1 plus 1 plus 7 plus 9 is 18. Ask yourself, is 18 divisible by 3? Yes, it is. 3 times 6 equals 18. Therefore, this number is divisible evenly by 3. Let's prove it. Three does not go into 1. I'll put a little X just to keep that spot filled. 3 goes into 11 3 times. 3 times 3 is 9. The difference here is 2, and we bring down the 7. 3 goes into 27 9 times. We multiply, we subtract, we bring down. 3 goes into 9 3 times. We multiply, we subtract. There's no more to bring down. Our problem is finished. And we've learned that 3 times 393 does in fact equal 1,179. Therefore, this number is divisible by 3. Now, you could certainly go through this entire process if you are ever asked if 1,179 is divisible by 3, or you could take the shortcut trick, add the sum of all the digits. Is the total divisible by 3? If it is, then the number is divisible by 3. Let's add 1 plus 5 plus 5 plus 6, and we see that the sum here is 17. Is 17 divisible by 3? No. Therefore, this entire number is not divisible by 3. Let's turn the page and see how we've done here. And we do see that the only number of these three that's divisible by 3 is 1179. The same can be done to check for divisibility by 9. Add the sum of the digits. Ask yourself, is the sum divisible by 9? If it is, the entire number is divisible by 9. It's time for you to go on and do your lesson practice. This has gone on quite long enough. I would like you to write out and list all of the factors of these numbers. Please follow the sample that I showed, where you write the number, put a colon, begin with 1, leave a big space, do 14, hop back to the beginning, 2, hop to the other end and write its match, because 2 times 7 equals 14, 3, 4, 5, and we find out that there are no others. I've just done A for you. The factors of 14 are 1, 2, 7, and 4. This is how I want you to solve and write out the problem, please. Your lesson practice continues on page 93. You are asked how many different factors do each of these numbers have? In this case, you again need to factor each of the numbers and then count how many factors there are. Please just do E and G here. And then I want you to do your divisibility tests for each of these numbers. Ask yourself, is it divisible by 2? If it is, write it down. Is it divisible by 3? If it is, write it down. Is it divisible by 5? If the answer is yes, write it down. In other words, what you'll be doing is putting each of these numbers through the divisibility tests for 2, 3, 5, 7, or 2, 3, 5, 9, and 10.